Gaseous state of matter. Revision notes by Decroly Education Center. The matter is made up of very small particles called molecules. Molecules are made up of a number of atoms of either the same or different elements which are bonded together. The Greek philosopher called Leucippus and his pupils Democritus, 460 to 310 BC, are believed to be the founders of the atomic theory of matter. They speculated that all matter is made up of identical, indivisible particles called atoms separated by empty space. The existence of molecules suggested by Leucippus and Democritus has been shown by experimental results produced by the English chemist John Dalton in 1808, whose theory proposed that matter was composed of tiny indivisible particles that he then called ultimate particles, now known as atoms. His theory further states that every pure substance is made up of a single type of atoms or a combination of different atoms called molecules. In 1600s, Boyle tried to explain the observed properties of gases in terms of molecules, their smallest particles. This will be detailed in the gas laws. Daniel Bernoulli, 1700 to 1782, was the first to explain the law which Boyle discovered. He also related temperature and molecular motion directly, calculated the pressure of a gas from collisions of the molecules with the walls of the containing vessel, and inferred that when the temperature increases, the velocity of the molecules increases also. The kinetic molecular theory states that the particles that the matter is made up with are always moving and they often bump into each other. This random motion is present in varying amount in solids, liquids, and gases. The assumptions of kinetic theory of matter can be summarized in the following points. All matter is made up of particles called molecules. In normal circumstances it exists in three states. All the molecules of a given substance are alike in all respects. The molecules are separated from one another by the intermolecular space, which is more than the diameter of the molecule itself. The molecules attract each other with a force called intermolecular force, which is strongest in solids and weakest in gases. Molecules are in constant motion. The temperature of a substance is proportional to the average kinetic energy of all the molecules of the substance. States of matter. Matter exists in the three states of solids, liquids, and gas. The physical difference between these three states lies in the arrangement and behavior of their molecules. These differences can be explained in terms of the kinetic theory model, which states that matter is made up of very small particles called molecules. These molecules are in constant motion. The degree of movement, which is the measure of kinetic energy, depends upon the temperature. The higher the temperature, the faster the molecules move, and therefore the higher the kinetic energy. Notice that the heat energy of a substance is the total kinetic energy of all the molecules or atoms of that substance. Properties of gases. In the gaseous state, molecules are even further apart than in water. This implies that they have more freedom to move among themselves. Properties of gases. In gaseous state, the molecules move haphazardly and at high speed, and they are constantly colliding with each other and the walls of the container. These collisions are perfectly elastic, which means that the total kinetic energy of the particles before collision is equal to their total kinetic energy after collision. Remark: the spaces between the molecules of a gas are relatively large, so that much of the volume occupied by a gas is actually empty space. As a result, the intermolecular forces are almost negligible and the molecules are independent to each other. The increased speeds and the greater spacing between the molecules allow the gas to both fill any volume and also to be compressed, as opposed to expansion. Change of gaseous state. When a gas is cooled down, the motion of its particles slows down and the intermolecular spaces reduce. This results in the gas changing into liquid, the process known as condensation or liquefaction. Some substances such as carbon change directly from gas to solid and vice versa. This process, in both cases, is called sublimation, e.g., case of carbon dioxide or dry ice and naphthalene. Gas pressure. In trying to explain many physical properties of gases, the assumption below are generally made. A gas consists of a large number of particles called molecules. In some gases the molecules are monatomic, while in others they are diatomic or polyatomic. The molecules are in a state of continuous random motion in all directions and with various speeds. The volume of the molecules is negligible compared with the volume of the gas. As a result, large spaces exist between the molecules, and that is why a huge amount of gas can be compressed to a small fraction of its original volume, especially in the cylinders, if the pressure is increased. The rapidly moving molecules collide with one another and the walls of the container elastically. There is no loss of kinetic energy during the collisions. So they are in constant fast, vigorous motion. No attractive force exists between the molecules for an ideal gas. Heat applied to a gas increases the kinetic energy of the molecules. The total effect of the collisions they make on a body lying in the gas, or on the walls of the container, is called the pressure of gas. As the temperature rises or the volume is reduced, the collision becomes more frequent. Note that for a gas to be compressed in a very small container, it needs to be liquefied. Liquefied gases are gases which can become liquids at normal temperatures when they are inside cylinders under pressure. They exist inside the cylinder in a liquid-vapor balance or equilibrium. Initially the cylinder is almost full of liquid, and gas fills the space above the liquid. As gas is removed from the cylinder, enough liquid evaporates to replace it, keeping the pressure in the cylinder constant. Anhydrous ammonia, chlorine, propane, nitrous oxide, and carbon dioxide are examples of liquefied gases. The storage volume for a compressed gas can be calculated using Boyle's law that we shall elaborate later in our future videos. Thanks for your attention. Kindly like and share our videos. Please don't forget to subscribe and press the notification bell to be the first to receive the next learning video. You may also give us a comment to suggest what topic you would like us to cover. See you later.